Hello, everyone. My name is Priyanka Sarkar, and this is my project on the course AI for Product Management. I am going to be talking about the problem statement in this case. I'm building a statistical model to predict electrical energy output of a combined cycle power plant from a set of 9568 hourly average ambient environmental findings from sensor, so we can predict electrical energy output with optimal usage of resources available in the plant. As an electrical engineer, this gives me a lot of pleasure because this is extremely important. The modeling approach that I took, I'm going to use AutoML for model building and training in this case. I would go for supervised learning as a machine learning method, primarily because we want to predict a target variable, PE, and also because at least some of the past observations are known. I choose my task, I chose regression because this is to select one numerical target and not like a class. Feature selection, while selecting features, my top priority was to understand what features might influence the problem, what data do I have for this purpose, etc. In this case, the input feature of the data set considered was scatter plotted here. And based on this data visualization, I figured out ambient temperature was the most congenial one here to be chosen as a feature, followed by ambient pressure. From model building perspective, I will quickly show a demo in a short while where you will figure out why I chose that model. But in a summary, the algorithm I chose was multiple linear regression because I did try random forest and some other parametric algorithms with multiple factors as features. This one scored the best according to me. I will talk through the model evaluation as well because it's important to understand how my model fared. These are the data that I have. It is close to, I chose my choice metric was R square, which is a value of 0.961, very close to 1. And because the range is 0 to 1, I chose this one because R square coefficient of determination is different because it doesn't really measure the loss in a sense. Instead, it measures how well the model performs. This is 0.961, so I'm happy that my model works. The chief objectives of predicting what is the full load electrical power and what is the best optimal use of resources, that was achieved. There could be future investigations on how you test association with other variables or other time frames. With this, I will quickly run into how I actually created the model. So in Google Cloud, I went and took help from AutoML to create a test data set. In this case, I chose tabular and regression, chose my region, and this actually led me to upload a data set from the computer. Now, I had saved the data set that was provided in the project on my computer in a local drive, so it becomes easy for me to select the path and then select a cloud storage path for this and create the data set. In the interest of time, I will show you the previously put data set, which helped me do some data analysis. It gave me the null values, distinct values, generated some statistics for me, and I was ready to build my model. When I went to build my model, I am absolutely going to first start with choosing my region, train a new model. And here I choose my previous data because that would have been saved. The new one is yet to do. Then I choose regression and I choose continue. I give a description and I select my target, my output, in this case, PE. Then I do my feature store and I select what I like in my training options. I give a training time of about 2 hours. The minimum is 1, the node hour, but I choose 2, and this will let me know over email once the data is ready. Again, in the interest of time, I'm going to show you my previously deployed and tested training model. This is the value you saw. I chose R square for the reason I mentioned. In terms of feature importance also, the model feature that actually stood out was ambient temperature, closely followed by the value V. I then did a deploy, and this is what you see. I have deployed it, and I have tested the model. So it gives me a prediction of the error percentage and how long it really took. And also, it let me test the data in terms of how it fared. With this, I would like to call my model a pretty interesting exercise and a good one with 0.961 R square. Thank you so much for watching. I appreciate your time.